64A in the top right-hand corner. Oh, I didn't get to eat my apple and I'm starving. Alright, and I want to write our learning target down. Super sorry we didn't get to do that. So today's learning target is I can simplify any radical expression. So we have 4 different types that we're going to look at today. You looked at part 1 together. Part 2 has variables. Part 3 has fractions. Part 4 has conjugates, which is a lot of fun. So you use your perfect squares still in all of this. That's what we've been doing. That's why I left a note card up here. So use perfect squares. And if you don't have your perfect square note card still, you are welcome to make one. And I'll laminate it for you if you want. Well, I'm almost out of laminating sheets. I'll buy some more and laminate it for you. So for A, did you guys find that the biggest perfect square that went into 80 is 16? Mm-hmm. 16 and 5? Mm-hmm. And you took the square root of 16 and you got 4 root 5.
At first I thought you had to put 4 on this.
Yeah, it goes on the outside because once you take the square root of it, it comes out here. Does everybody understand? Because the square root of 16 is 4. We're kind of looking like zombies.
We get it.
Okay, so then for 180, the biggest perfect square that goes into it is what?
36.
36 and what? 36 and 5. Awesome. And then what's the square root of 36?
6.
So you have 6 root 5. And you say that as 6 root 5. So how do you say it?
6 root 5.
Woo! Then for number C, you first multiply 2 and 14 together. And that gives you the square root of 28. Now the reason you can multiply those together is because they're both under the radical. If they were not under the radical, you would not be able to multiply them together. Alright, you would not. Let me change how I just worded that. Say this was a 3 and this was a 5. You would multiply the 3 and 5 together and you would get 15. So since I'm writing this on my notes, you guys go ahead and add the 3 and 5 together. Now, you would not multiply that 3 and 2 or that 5 and 14 or the 3 and 14 or the 5 and 2 because they're not all under the radical. So you only multiply what's under the radical and then what's on the outside, you multiply it. Then you break down the 28. What's the biggest perfect square that goes into 28? 4 and what?
7.
And what's the square root of 4?
2.
So what are you going to do with that 2 and 15? Multiply. 2 times 15 is?
30.
Root 7.
Do you have any note cards?
I need some.
Anybody else need a note card to remake their perfect squares?
I shouldn't have threw it on. I was like, I ain't gonna need this no more.
I told you to keep it. And nobody listens to me.
Yeah, my phone is in my binder somewhere.
Nobody knows the trouble I've seen. Did you just say yours is probably in your binder?
Yeah, it's a mess, though.
Whose is this?
I put everything in like
Is this
a
Miss
5
Brewster's?
pouch.
No, this is Miss Jessica's. Okay. Do I need to put the note card here for you to copy?
Yes.
Alright, so these are the perfect squares. These are the square roots of the counting numbers, and that's why I coded it on the right. I'm going to pause the video while you guys copy this down. Please copy it fast so that we can do the second part of our lesson. I'm going to pass part 2. Part 2 has variables in it. So you still do it the same way, but remember, when we have a square root, we have a baby 2 right here. So the first thing we do is we break down the numbers. So what's the biggest perfect square that goes into 90? 9. So it's 9 and what?
10.
Okay. Now what's the square root of 9?
3.
And the 10 stays inside the house. Remember, the 9 it makes up of two 3s. They want to go outside and play, so that's why we got the 3 there. The 10 is by himself. He wants to stay inside and read Harry Potter. Does everybody understand?
Why'd you put it so far apart?
Because we got to put the letters in there. We got the variables. All right, now, to do the variables, does anybody remember what we do?
Subtract.
We divide. I was going to send you an email. Nope, it's right here.
Okay.
All right, so then to do the variables, you divide. 2 goes into 3 how many times?
Oh, I remember this.
Once, with how many left over? Okay? Does everybody understand how we got that?
Yeah, I remember how I did this now.
All right, 2 goes into 4 how many times?
Twice.
So y squared. Do we have any left over?
No, yeah.
Oh.
I remember how. Is that right?
2 goes into 4 2 times evenly. What's wrong with y'all? What's going on?
Right.
All right, 2 goes into 5 how many times? With how many left over?
One.
Okay, so I don't understand what's happening, but I'm going to show you a tip on this, okay? We have how many 3s?
Yeah, I remember how I do this now. I'm good.
We have 3 3s, and we need them in sets of 2. So we have 1 set of 2 with 1 left over.
I'm gonna start doing that.
That's why we have an X on the outside and an X on the inside. You are welcome to start doing that. Then we have how many 4s? How many Ys?
Right.
What? All right, how many sets of 2 do we have? 1, 2. That's why it's Y squared. And then we have how many Z's?
5.
All right, and how many sets of 2 do we have? 1, 2, with 1 left over. So that's why it's Z squared with 1 left over. Does everybody
All
understand?
right, for these.
So whatever's left over, we put under the root.
Yeah. Yes, whatever's left over goes under the root. Yes. That. These are the people that want to stay inside and read Harry Potter. These are the people that want to go outside and play and get eaten by zombies.
Dang.
All right, so let's look at B. What's the biggest perfect square that goes into 32?
16.
16. 16 and what? 2. All right, what's the square root of 16? And what stays inside the house to read Harry Potter? 2. All right, let's do our variables. Remember, it's a baby 2. 2 goes into 2 for R's how many times? 1. All right, 2 goes into 4 how many times?
Twice.
Okay, squared. 2 goes into t to the 5th how many times?
T squared.
But a t left over. So then put a hook on the end of the radical so we know it ends. It is magic. It's like I'm a wizard.
I did Z.
One egg just stay inside of C.
It would. All right, now let's look at C. C, 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 C. It's a good day, taters. It's a good day. What's the biggest perfect square that goes into 56? 14 is not a perfect square.
Well, 2. Or 4, my bad.
4 and what?
14.
Okay.
I just already.
All right, and then the square root of 4 is? What stays in the house?
14.
All right, now, does 2 go into 1? So X stays in the house. Does 2 go into 10? 5 times, so Y to the 5th. Do we have any left over? No. And then Z's, 2 goes into 5?
Twice.
With?
One left over.
Boom.
Ow.
So now you should be able to do through 13 on your homework. We ready to do part 3? Does anybody have any questions before we go any further? Because I know we're kind of doing it fast, but I want to make sure we answer all questions. Yes.
Okay, so there's a perfect, or like a perfect square, like, like on the inside of the, like, if it were to say
36?
36, yeah,
It would just be 6 out here. And no number left.
okay.
Yeah, good question. All right, so part 3, rationalizing a denominator. Now, what that means is you cannot have we cannot have a radical in the denominator. So what we're going to do is we're going to do A and B 2 different ways, and you're going to tell me which one you like the most. So the first thing we're going to do is we're going to reduce this fraction. So let's make a note that says reduce. Blair, get it together. What do 15 and 35 have in common?
5.
5. So we're going to reduce that by 5. And that's going to be the square root of 7 divided by 3. 7/3. Now what you do next to rationalize, break it apart. So this is the same thing as writing the square root of 7 divided by the square root of 3.
That's it?
I'm not done. I'm just pausing so you can see what I did. I'm taking a breath. Now, we cannot have a square root in the denominator, so you have to rationalize it. The way you rationalize it is you multiply the top and bottom of the fraction by the square root of 3. So I'm going to multiply square root of 3 and square root of 3, top and bottom. I don't know why my fraction looks so weird.
So 21 on top.
Wait.
Yes, that's what she said.
It is. Square root of 3 and square root of 3. I don't know why it looks weird or why I can't write. I don't know why I do the things that I do.
That is rich.
Now, on the top, you're going to have the square root of 21. Now, when you multiply these together, you'll end up with the square root of 9, which is 3, right? Anytime you multiply two numbers together that are under the radical disappears if it's the same thing. So this is just 3. Because the square root of 9 is 3, right? So normally we would write the square root of 9, but instead we just turn it into 3. We simplify. So if I have the square root of 2 times the square root of 2, that's 2. If I have the square root of 5 times the square root of 5, that's 5. If I have the square root of 7 times the square root of 7, that's 7.
So it's still
That's
like,
only if they're the same. Then you multiply. Just like we did up here. If they're not the same, you just multiply them. Stop making weird noises. So then your answer is the square root of 21 divided by 3.
So basically just simplify it down.
Yeah. That's why it says whatever. Alright, now for B, before we go. Now B, you can do it two ways. You can either reduce first or you can rationalize first. What I mean by rationalize is multiply by this denominator. So do you guys want to reduce these first or rationalize? Who votes reduce? Who votes rationalize? Alright, we're rationalizing first. Don't worry, you may choose to reduce from now on after this. So the first thing you do is you multiply the top and the bottom by the square root of 12.
It would be 12.
And it would be 12 in the denominator. What's 6 times 12?
72.
Now, is there a perfect square that goes into 72?
Yes.
Yes, so you have to simplify. What's the biggest perfect square that goes into 72?
36.
And what's the square root of 36?
6.
So we end up with 6, and what's on the inside?
Yeah, I'm doing that.
2y divided by 12. Now can we reduce this?
Yes.
And what is 6/12 reduced to?
1 half.
So 2y divided by 2. Now, isn't it easier to reduce first than rationalize?
Yes.
Yeah.
Because you did all that.
Because if you reduce first, you would have 1/2 here. It would just be the square root of y, or it would be, my words, Blair.
16 on the board.
You go through, I want you to go through 20. With the variables, you do the same thing. So try, I want you to do C, divide by 5, divide by 5, and you get the square root of 9 divided by the square root of 2, which is 3 divided by root 2, and then rationalize. Do that tonight. I'll post the video. I love you. Goodbye.